All right. 5.1 day one notes. Now, if you're watching this in class, then you obviously have the staple packet. Please keep up with that for the next 3 lessons. Thank you very much. Don't lose it. Everybody else, these are posted on Google Classroom. Now, we're looking at antiderivatives and indefinite intervals. Alright, the goal right here is to given the derivative, find the original function. Alright, what the original function could be, or find the original function. So, if this is the derivative, well then you gotta remember that I'm going to show you rules to always find these, but the rule is basically this. Alright, if it's a constant, then you add x. Alright, if it's a constant, add x. So this right here, the original function, would actually be x. Sorry, 6x plus c. Alright, and that c could be anything, any constant. Like for example, if I had 6x plus 7. Alright, well when I take the derivative of this, it doesn't matter, it's still going to be 6. So that constant can be anything. You just put c to denote that it's a constant. Alright, for this next example right here, this one, the derivative of g is 3x squared. Well, the rule is you add 1. Okay? You add 1 and then you divide by your new exponent. Alright, so 2 plus 1 is 3. So you divide by 3 and this will give you x cubed. So the original function g of x equals x cubed. Alright, let me show you. Take x cubed and find the derivative. If I found the derivative, that would be 3x squared, right? Which is what we started with. So we're basically undoing that, okay? But you gotta add c plus c, because it's always plus a constant. Any constant will work. Any constant will work. 0, 1, 2, 3, 4, 5, negative, whatever. Any constant will work. Alright. Again, look at h of t. H prime of t, this is a derivative. You want to undo the derivative, so again, add 1. Alright, and then you would divide that by 3 because 2 plus 1 is 3. So, h, the original h is really 18 divided by 3 is 6. T cubed plus c. Okay. Because 3 times 6 is 18. And then you reduce by 1. That's how you get the derivative. You're doing integrals or antiderivatives. So we're basically undoing derivatives. Okay? Now the operation of determining the original function from its derivative is the inverse operation of differentiation. It is called anti-differentiation. An antiderivative, also called an integral. Okay, antiderivative, also called a derivative. A function f is an antiderivative of a function f if for every x in the domain of f, it follows that f prime of x equals f of x. A function that the given function would be the derivative of, okay? So, we just got to do more examples. But before we do that, let's look at the notation. This symbol right here, alright, when I write it a lot, you'll see it looks like that. Alright, that's the integral sign. Alright, and then this right here, this is the integral sign of f of x dx. That means indefinite integral. Indefinite integral. Integral sign, integrand, differential, antiderivative, plus c, your constant. Alright, don't forget your plus c for your indefinite integrals, which is what we're looking at today. It says, is f of x equals x cubed the only function that has a derivative of f of x equals 3x squared? Well, of course not. Alright, you can have x cubed plus 7. Like I told you, you gotta have a c. Alright, some constant. This has a derivative. Alright, this has a derivative of 3x squared. Right, what if I had x cubed plus 100? Still, the derivative is going to be 3x squared, right? I'm sorry. Yeah, 3x squared. Even if you had x cubed plus or minus, it doesn't matter. You can say minus. Let's just throw equals there. Minus 7,452. This derivative is still 3x squared. You see what I'm saying? So the C just stands for constant. And you're not looking for the constant. You're just looking for, you're just denoting when you find the integral of this, that a constant can go here and still have the same derivative of 3x squared. Alright, rewrite each antiderivative using integral notation. Alright. So, what we're going to do here is, in integral notation, we just rewrite this as the derivative of 3, right? Because see, this is the derivative. The derivative of 3x is 3. So we're going to rewrite it in integral notation. So the integral of 3 dx, alright, the integral of 3 dx equals 3x plus c. Alright, so we already know what the derivative is, right? The derivative of 3x, sorry. Remember, this notation is the derivative, so the derivative with respect to x is 3. So now, write the integral of it. Alright, well again, you would just add, if it's a constant, just add x. So 3x plus c. Number 2 here, the derivative, alright, with respect to x of x squared is 2x, and we know that because you would multiply by 2, reduce by 1, so 2 minus 1 is 1, so that's how you get 2x. Now, write it using integral notation. So the derivative of 2x dx equals x squared plus c. Alright, and again, c just covers all values. Okay. And last one, write this in integral notation. Alright, right, this is integral notation. So the derivative of dx, or excuse me, the derivative with respect to t, alright, is 3t squared. Oh my gosh, 3t cubed. And we know that the derivative of this, 3 times 3 is 9, reduced by 1 to 2. That's the derivative. Now for the integral, we're going to say that the integral of 9t squared dx equals, and you undo this, okay? So again, I'm just going to go over how you undo it in the beginning. You have 9, you're going to add 1 to the exponent, and then divide that out. So 9 divided by 3 is 3. Alright, add 1 to the exponent, which is 3, now divide by that exponent, the same exponent. And there you go, you have your original 3t squared, 3t cubed. Alright. Alright, number 4 here. Alright, here are the basic rules. Alright, here are the basic rules. Make sure you know where to locate this. This is the constant rule. Alright, if you have the integral of a constant k, then it's just the k times x plus c. The constant multiple rule, k times f of x dx. You can pull the constant outside, which we'll get there. We'll get there. And then find the integral of the function. The sum rule. The sum rule tells us that we can integrate these separately. Alright, the function f of x plus the function of g of x. The difference rule, again, you can integrate that separately. And then the power rule. Alright, the power rule would be as follows. It would be x to the n plus 1 divided by n plus 1, which is what we just did, plus c. Okay? We just did that right here. When we went, the integral of this would be 2 plus 1 divided by 2 plus 1. N plus 1 divided by n plus 1. So in this case, 2 plus 1 is 3 divided by 2 plus 1, which is still 3. So let's do a couple examples right here. Alright, so let's find each indefinite integral. Well, this applies to the constant rule. Alright, this is the constant rule. So we would have, look at the constant rule. The constant rule, the integral of a constant k is just k times x plus c. So this is a constant. So the integral of 5 to dx will just be 5x, the constant times x plus c. This is also a constant, the integral of -1 dr. So this is with respect to r instead of x, you got r. So -1 is a constant, so you'll have -1 r plus c, or you can rewrite it as -r plus c. Alright, constant, integral of a constant is just the constant times the variable. Constant times x, constant times r in this case. Right here for number 2, another constant. Alright, with respect to t, so this integral would be 2t plus c. Number 7 here, this one has an x. So remember, we're going to, when we integrate this, we're going to do 5x. Remember the power is 1 here, so we're going to do 1 plus 1 divided by 1 plus 1. Alright, plus c, and then simplify this. X to the 1 plus 1 is 2, so you have 5x to the second divided by 2. So 5x squared over 2 plus c. Alright, that's all I got. This concludes your notes for today. You have some practice problems here on 362. If you look in the back of your packet that I gave you in class, you'll see the page 362, and here are the problems. Also, I want to point out, alright, I want to cover with you the most missed problems from the test yesterday. Because I want to do a retake on Friday. So let's go ahead and do it. The first one said find the relative extremas. Alright, relative extremas of f of x equals 4x to the 4th minus 64x cubed plus 4. Alright, and then it says use the second derivative where applicable. Okay, so that kind of hints that, hey, we probably want to test the first derivative first. So the first derivative here is going to be 16x cubed minus 192x squared. Alright, and then remember we take that and set it equal to 0. Alright, with this one we can factor out of 16 and the x squared. So you get 16x squared times x minus 12. And so you set this factor equal to 0, and you set this factor equal to 0. And you should get divided by 16 is still 0. And then square root both sides, you get x equals 0. And for this one, you add 12. And you get x equals 12. So of course you gotta go to your wiggle line test. By the way, I hope y'all are taking notes on this and not just watching me do it, because again, retake on Friday, I'm trying to review with you. So 0, 12, and we test values on the different sides of those values. So I'm gonna test I'll test -1, I'll test 1, and I'll test 13, I guess. Alright. And we test those in the first derivative. So we test f prime of -1, so we're going to test it right here. So -1 here will be a negative, right? So this is negative, and the -1 here will be a positive. So it's still negative, so this is negative, which tells me, in fact, this is -208 if you plug it in. So that tells me that this is a decrease on this side. And so now I'm going to do f of 1, and I'm going to plug 1 in right here. And that becomes 1 cubed is 1 times 16 is 16. This is 1 squared, which is 1 times a negative 192 is negative 192, and 16 minus 192 is going to be a negative 176. So this is also a decrease. So when you have this point 0, you can't have a decrease and then a decrease. That's a straight line. So this is not a max or a min. Alright, I'm going to show you in a graph in a second. That is, so we got a decrease right here on the left side of 12. And then let's test F prime of 13. Alright, I want to plug it in real quick. So I got 16 times 13 cubed minus 192 times 13 squared. And you can work this out in your calculator, guys. I'm just working it out in mine. And this is a positive 2,704. So this side is positive. So what that means is that this is a decrease to 12 and then an increase. So 12 is a minimum. Alright, this is the minimum. Alright, decrease, increase. This is the minimum. Alright, and we said, what is the relative extrema? Well, that's the relative extrema. It's 12. Alright, it's 12. So when you answer this question, alright, it's going to ask, was it a max or a min? You will say, of course, it's a minimum. And then it goes, I think it said, find the relative extrema, and the relative extrema is x equals 12. And in that blank, you could have just put 12, if I'm not mistaken. Okay, you could have just put 12. Oops, that's not really 12. Fix it. So don't forget that, alright? For the next problem, that was the most missed, that was number 6. And by the way, I'm going to do 6 problems, okay? I'm going to do 6 most missed problems. And that problem was find the relative, again, same concept. Find the relative extrema for f of x here, where f of x is equal to, in this case, it was x to the 2/3 minus 1. Now this one, I'm really surprised this was missing. I'm going to show you why. Here's the reason why. Because I went to our test review, and the only difference is this went from a minus 1 to a minus 3. The test review is minus 3. On the problem, on the actual test, it was minus 1. Same problem. Okay. But anyway, same rules apply. We should have been able to do it. Find your first derivative. So that first derivative is 2/3 x. Remember, reduce this by 1 or 3 over 3, which is a negative 1/3. Which again I rewrote as 2 over 3 times the cube root of x, like that. I'll move that to the bottom. Now we take that. Times 3, and we set it equal to 0. And so if you multiply this whole, both sides, by 3 times the cube root of x, and multiply this side by 3 times the cube root of x, right? That'll cancel. This is 0, so you have 2 equals 0, and this is undefined. Alright, it's undefined. I know that's not undefined. You just sloppy, right? But still, I just want to show you on your test review key, it was undefined. Right? So now we test it in the first derivative like we did here. Okay. Find our x value. In this case, it was just 0. Oh, your test is 0. And your wiggle line test, right? You got 0. It's undefined. When it's undefined, test 0. So here's 0. Alright, we use 0. So I want to test negative 1 and 1 in our first derivative. Oh man, of negative 1. So you plug negative 1 into this, and that'll give you negative 1 and cube root of negative 1 is still negative 1. So you have negative 3. That'll be a negative 2/3, which is a decrease. And then you do f prime of 1. Put 1 here. That's the cube root of 1 is 1 times 3 is 3. So that's 2 over 3, just 2/3, just positive. That's an increase. So that means that this is a minimum, right? Decrease. We form this right here. That means that's a minimum. So you have a minimum at x equals 0. This is your extreme one. Because it's not only a minimum, it's the most extreme minimum. Alright, so this was a minimum at x equals 0. So, man, shot by that one. Alright, 4 more. I just want to show you. This problem right here. I'm going to show you what it says. It said, find the length, or find the length and the width of a rectangle has a prism. Let me see, it has a perimeter of 56. Alright, so look, remember with these rectangles, it helps to draw the picture. So we know it has a perimeter of 56, which means if I add x plus y plus x plus y, it'll give me 56. So in this case, 2 x's plus 2 y's equals 56. And then it says find the maximum area. So we need to isolate y, okay? Isolate y, so subtract 2x, and then divide by that 2, and then y is now by itself. That's our secondary equation. We take that, we plug it in over here. Oh, by the way, we can reduce this right here. Can we divide that? Yeah. Divide by 2. 28. So we have 28 minus x. I'm going to do that. 56 divided by 2 is 28. Negative 2x divided by 2 is negative x. And then we plug that in right here in terms of y. Distribute that. And then find your derivative. 28x. The derivative of 28x is 28. And the derivative of negative x squared is negative 2x. And then we set that equal to 0. Add 2x to the right side. Divide by 2. And we get x equals 14. And then all you do is come over here. Solve for y. We know x is 14. And 28 minus 14 is 14. So we should have had both x and y equals 14. So that one was highly missed. That was surprising. Let's see here. Problem 10. This one. Okay. Now this one contained a picture like this. Those 2 rectangles. Or I'm going to do it like this. There we go. And it had this was y and this was x and this was x. Okay. And the picture said the rancher had 680 feet of fencing to enclose 2 adjacent rectangular corrals. Alright, here's the 2 rectangular corrals. The dimensions should be used so that the enclosed area, okay, area is a maximum. That's our primary. Well, let's figure out this. If this is y, then this long leg right here is y, and so is this. So that's 3y. We also see if this is x and this is x, this is x, and so is that. So that's 4x plus 3y, and we know it's going to equal 680. Okay? So we isolate y again, we subtract 4x, and then we're going to divide both sides by 3, and then isolate y. That's an equal sign. Alright, so we got, this doesn't simplify, so I'm going to actually leave it back like this. And sorry, man, it's just getting kind of long, but I really want to go over this video. Alright, so you guys can be successful on your next attempt on your retest on Friday in class. Alright, oh no, equals 680 equals y. I don't know what I'm doing. Alright, so now we take our y, we plug it in over here. So you get a equals x times 680 minus 4x all over 3. And I'm actually going to leave it like that. I don't know why I wrote it back, because it'll make more sense to just derive it like this. Alright. So distribute your x. A equals 680x, or 680 thirds, over times x minus 4 thirds x squared. Now find the derivative. X, this is 1 times 680 is 680. And right here, 2 times a negative 4 is going to be a negative 8 over 3x. And now we still set this equal to 0. Add over 8 thirds x. And now multiply by 3 on both sides. 680 equals 8x, sorry. And then 680 divided by 8 is going to give you 85. So divide by 8 on both sides, you get 85 equals x. Now all you do is take your 85 and plug it in right here. I'm jumbled up here, but I'm going to write it out anyway. So you have 680 minus 4 times 85. I'll write that needle so you can see it. 4 times 85. All over 3 will give us y. Alright, so I'm going to do that on my calculator real quick. 680 minus 4 times 85. That's 340. And then we divide that by 3, and that gives us 13.3. I'm sorry, 113.3. You can just put 113.3. Alright, so y and x is 85. Alright. Man, I know we had one just like that on the review. So it looks like what's in the review. There was one just like it, I remember. Oh, it's the French problem. This one. Same type problem. 4x plus 3y equals the amount of distance we have. The same problem. Okay, let's keep going, because I don't want to take too much longer. We got 11 and 14, so 2 more. 11 here. Find the closest point to this point right here. Shoot, if we can do that. There it is. By the way, that should be x squared. Let me fix that. Alright, so remember, this starts by finding the distance formula. Now, remember I told you, you don't even have to look at the radical. Take what's underneath the radical. And by the way, this is x, this is y. So x minus 7 squared minus y, which is 0.5. Oh, I'm sorry. Y minus 0.5 squared. Okay. Plus, I don't know why. Late, I guess. But anyway, that's how you start off. Okay. Now you see right here where it says f of x equals x squared. That's the same thing as y equals x squared, right? F of x and y is the same thing. So we're going to take that x squared and put it right here in place of y. So we have x minus 7 squared plus x squared minus 0.5 Now we're going to FOIL this, which is x squared minus 14x plus 49. Then we got to square this one. So x squared times x squared is x to the fourth. And then I have x squared times negative 0.5 and x squared times negative 0.5, which is going to be a negative 1. X squared, or just a negative x squared. For that, I'm not going to do it. And then negative 0.5 times a negative 0.5 is actually a positive 1/4. This is working out almost identical to the Now, you'll see that x squared and negative x squared cancels. And so you have x to the fourth minus 14x plus 49 and 1/4. Alright, I just added 49 plus 1/4 is 49 and a fourth. Now find the derivative of this. I'll say d prime since it's another d. So you get 4x cubed minus 14. That's a constant, so it's gone. Now we still take this, set it equal to 0. Add 14. Divide by 4. And that reduces, by the way, to 7 halves. Yeah, 7 halves. And then cube root both sides. And so you end up with the cube root of 7 halves. Alright. Now, when I punch that in my calculator, that gave me 1.5. So this is about 1.5. So there's x, about 1.5. Now we take that, alright, and we just plug it in right here to find y. And 1.5 squared is going to give you a 2.3. So y is 2.3. And x is approximately 1.5. There you go. That's the closest point right there. Alright, one more problem. It was 14. Okay. This one goes back to the last test because it was a missed problem and we got to spiral it back in for the half-life problem, right? Alright, so we use this equation, y equals c ekt. And remember, step 1 is find k, and then create an equation from the given information. So we know that we're going to have 1/2 of y. Alright. Or, I won't even say y. We're going to say 1/2 the constant because you start with c. So we're going to have 1/2 of c. Alright. And 1,599 years. That we know. Alright, because it told us we're going to have half of this life, half of radium in 1,599 years. So what we do is, we can solve this by dividing by c on both sides. Alright. Oops, that's 5. So divide by c. C cancels. Now, I got this ek to the 1,599. Well, remember, you can't just solve that because of the variable, so you need to take the natural log of both sides. So I want a natural log of this side and natural log of this side. And e and ln cancels. Natural log of 1/2 equals 1,599k. And then you just divide by 1,599. natural log of 1/2 of 1.5 divided by 1,599. So that gives me negative 4.33 e to the negative 4. So basically what that is, 4.33, I need to move left. I need 3 zeros in front of that. So negative point, well here, I'll do it. So K equals negative 0.000433. There we go. 4 decimal places behind, or 4 spaces behind the decimal. Okay. Now we're going to take that information right here, and we're going to say that, all right, I know I'm gonna have how many grams? 2.5 grams. 2.5 grams of some C. Of K times 5,000. So in 5,000 years, at this rate of proportionality, I'm gonna have 2.5 grams. So now all you gotta do is solve this. And so for C to find the initial amount, so we're gonna divide by this. On both sides. That's why you need a calculator, right? So I'm going to do that right here. 4,000. Oh, not 4,000, but 2.5. Divided by E. So second, natural log, that'll give you E to the negative 0.1234433 times 5,000. And we get 21.79 grams of this stuff. 21.79 grams of radium is what we started with. This is C. Okay. So again, man, sorry this got long, 37 minutes. I hope this helps you prepare for